Hi, this is Gabe Garfield, and for those of you who don't know me, I'm a meteorologist and storm chaser. And since the first big system of the year is coming up for severe weather, I thought it would be fun to give a little map briefing. Today's date is February 22nd, 2024. So I'll start with the Storm Prediction Center severe weather outlook for days 4 through 8. And as you can see here, the SPC has assessed the risk for severe weather for day 6, which would be Tuesday, at 15% from eastern Oklahoma all the way up into northern Illinois. And then on day 7, that risk shifts into the Mississippi Valley and Tennessee valleys. And so to begin our map discussion, I thought it would be good to start with a single run of the GFS. Obviously, ensembles at this range would probably give more information as to uncertainty, but I think a deterministic run can give you at least a little bit more of the feel and the flavor for how this might evolve. And we'll also discuss the ensemble at the end of this briefing. So starting at 250 millibars, you can see here that right now the flow over the United States, particularly the southern United States, is fast and from the west to the east, and that is called zonal flow. You don't see too many dips here. Do see somewhat of a dip, a little bit of trough, a little bit off screen there. And as time goes on, you can see there's a little bit of a shortwave trough that digs into the eastern and southeastern United States. And that actually, as you'll see later, is associated with the surface front that actually sweeps through the Gulf of Mexico and does play a little bit of trouble for moisture return and quality. So we'll look into that shortly. And so that happens over the weekend. You can see the timing of this is on Saturday morning. And then as time goes on, you can kind of see some ridging developing over the central United States. Split flow, obviously a pretty strong southern stream. The northern stream gets pretty close. And then as time goes on, you can kind of see these streams come together as the big system arrives. You can see that punching in the northwest United States. And the flow, as those streams come together, the energy gets pretty strong and the flow gets strong. And you can see those blues coming up here at 250 millibars, indicating winds at roughly 30,000 feet, anywhere from 170 to almost 200 knots. So really fast flow. And this is the kind of thing that if you're in an airplane heading from somewhere in the west to somewhere in the eastern United States, you're going to fly there pretty fast. In terms of Tuesday, you can see here at 0Z on Wednesday, which is Tuesday evening, what you see is again pretty zonal flow, a little bit more from southwest to northeast here, but overall relatively low amplitude, which means that the forcing at from a large scale perspective for lift to develop low pressure and thunderstorms as well is a little bit on the lower side than you usually see this time of year. You usually see troughs that are a little bit more amplified, meaning that they go up and down a little bit more north to south. And then you can see the trough axis out here, kind of out towards Utah and Arizona and eastern California. And one thing to note is that most of the forcing for lift is out to the west. There may be a little bit of a left front quadrant aspect of divergence out in the central plains, but otherwise, really pretty subtle forcing. Likely that we'll get some more advection, so that may be sort of a large scale forcing for lift elsewhere. But in terms of uh, straight jet theory, left front quad, right rear quad, and ageostrophic curvature divergence. Not seeing a whole lot going on here on Tuesday. But as we shift into Wednesday, you'll notice that the trough becomes a bit more amplified. So you would expect to see the forcing for convection increasing. And then we almost get a little bit of a couple jet structure here where you see a lead jet off into Canada and then a bit of a trailing jet streak over here in the Mississippi Valley and point southwestward. So you might expect to see a little bit more enhanced lift, particularly over the um, Great Lakes region, maybe a little bit into the upper Midwest. The right rear quad is essentially over eastern Texas in Louisiana, so you might expect some rising motion out here. And then obviously with the trough axis getting closer and then the trough getting more amplified, you might expect, just generally speaking, more large scale lift just east of that trough axis. So overall, I would say that there's probably a lot of lift going on here. Probably will be a lot of thunderstorms on Wednesday. Storm mode for supercells, storm mode for the purpose of forecasting tornadoes might be a little bit messy, but we'll see how that pans out. It's a little far out to tell that. Okay, let's go down to 500 millibars. So we can kind of go in reverse here, and you can see at 500 millibars, that trough I was telling you about at the beginning really starts to that lead trough down in the southeast United States. It was pretty strong and drags a front through the Gulf, so not great for developing that moisture that you need for severe thunderstorms and tornadoes. And that kind of ejects out on Saturday and into Sunday. So it gives you maybe 48 hours of moisture recovery, but really for moisture return, the kind that you really want to see for big tornado events, you do kind of want to see 3 or 4 days of a good fetch over the Gulf of Mexico. But overall, I think there will be some time for that moisture return to occur. Now you see as the jet kind of comes through in the northwest United States and merges with the subtropical jet stream, you can see here that the flow starts to increase. That jet streak, the trailing jet streak is mostly positively tilted, but when they come here together, they become a little bit more neutral, particularly as we come into Wednesday. And the flow is fast, not really much different than what we described at 250 millibars. You will have some vorticity advection going on here. So if you're imagining, the curvature right here kind of being like a little bit of like a bowling ball, you might imagine there's a little bit of curvature here, and that curvature creates some spin, and that spin, as it moves along and as it advected or moved by the wind, would create some rising motion out ahead of that spin. And so, again, kind of just really anywhere east of that trough axis is where you'd expect that to happen. That really starts to impinge upon the plains and into the Mississippi Valley from late Tuesday into early Wednesday, and then everywhere essentially on Wednesday afternoon and evening. And in terms of the vorticity, so we talked about that in terms of wind. You can really see that here in the vorticity map, that bowling ball and the advection associated with that. So anywhere where you see essentially the ISO heights running over that vorticity lobe, that would be where you would expect vorticity advection to occur, and pretty strong forcing for convection. And then something I also would like to look at is the lapse rate. So this is something I think that will be pretty important for this event. So you see, starting out here, right around this time frame, you see the lapse rates aren't terribly impressive across the plains, but as westerly flow over the mountains causes compressional warming as it's moving down slope, this leads to kind of a nice differential in temperature known as the elevated mixed layer, which creates steep lapse rates. And you can kind of see that yellow to orange area developing over the plains with a westerly flow. And the stronger that flow is, the more impressive those lapse rates become. And by the time Monday comes around, you really do see pretty substantial elevated mixed layer developing over the plains, and then it kind of becomes detached on Monday into Tuesday, and then moves over the Mississippi Valley on Tuesday into Wednesday. And then by the time Wednesday morning rolls around, you see those lapse rates are exhausted, presumably by convection that's ongoing. So it's removing that temperature differential over the Mississippi Valley. So overall, that would speak to the idea that there is some pretty good potential for CAPE maybe on Tuesday into Wednesday. You might have a kind of a low CAPE scenario owing to the weakening of lapse rates because of all the convection. And then going into 700 millibars, what you do see here is pretty much the same thing that you see at 500 millibars, pretty flat flow, pretty westerly. And then as that trough comes in, at the upper levels, you start to see the flow kind of come together. The ice heights come together, and you start to see faster flow. And then the trough at 700 millibars develops and really strengthens by the time you get into Wednesday. So very fast flow. So you would expect to see photographs that have a pretty good shape on Wednesday. So certainly from a kinematic standpoint, from a shear standpoint, probably going to be some pretty good shear, particularly on Wednesday. The question is, whether or not there will be uh, good moisture for that as well. And also storm mode could be a question. 850, kind of the same story. You do see that veering flow out of the southwest on, let's get to Tuesday here. So you can kind of see up into the southern plains, pretty veered west-southwesterly flow, but further south into eastern Texas, where actually you'll find later that's where the moisture is. That flows a little bit more from the south, and that will lend towards better shaped photographs, more favorable for supercells and for tornadoes. And then as you go into Wednesday, that really increases that flow from the southwest. So we're definitely looking at, I would say, some pretty substantial low level shear owing to this. Also, you will probably see a lot of moisture advection as well, which will certainly help. Although this doesn't, you can see that these stronger winds don't really go into the northern Gulf much, so we may not see as strong of advection from the Gulf. So moisture may be somewhat limited, but we'll see. And then in terms of temperature, this will just to show you kind of where those winds are. Let me scroll up a little bit so you can see the date. So on about midday on Tuesday, you can kind of see relatively veered flow over most of the plains, and then they start to back a little bit as you go into Arkansas and Louisiana. And then as the trough begins to approach the plains, you start to see a little bit of backing over Texas, but overall, I think the wind fields are not particularly strong. Now, where the risk has been assessed from eastern Oklahoma into northern Illinois, you can see a little bit more backing, but the temperatures are a bit cool. I'm a little bit incredulous about the possibility of severe weather, maybe a little bit of elevated severe weather. Surface-based storms, the cap may be a little bit on the strong side. We'll see that here in a second, but we'll see. So in terms of the dew point temperature, at the same time, you kind of see dew point temperatures are relatively low where the risk is, so lower 60s at max, really, in eastern Oklahoma, and then really drop to the upper 50s into Illinois. And just out of curiosity, I'm kind of interested to see what that looks like. Let's look at a sounding and see how that moisture distribution is through height as well as temperature. Maybe get a sense of whether that will amount to much. And you can see here that this is kind of a marginal severe type of situation. Partials are not particularly favorable for the potential of severe weather up here. Now there may be some convective feedback going on, so who knows whether there will be actual severe weather there that is surface based. Further south into um, southeastern Oklahoma, let's take a look at that and see what that looks like. And you can see here a little bit more favorable in terms of the lapse rates in the lowest, say, 500 millibars. Pretty good dew points. Not bad in terms of moisture depth, probably about 100 to 125 millibars. A little bit of a dry zone, maybe some subsidence that's happening there, that we see that little inversion there. So it'll be interesting to see how this all happens. There might be some parameterization going on. Really, again, probably not a great idea to be looking at soundings this far out, but just gives you an idea of kind of what we might be expecting. And then further south, you really do see those higher dew points. But as you go down here, you do see, I believe, you'll see some better moisture, but also we do see a little bit more capping down here. Now look at those photographs. That's very nice. So if we do get some better moisture, and that's something that we'll probably want to watch over the weekend, is to see that southeastern United States system, whether or not it will actually drag that cold front through the Gulf of Mexico. Let me show you that in the temperature so you can really see what I'm talking about. Over the weekend, you can see the flow over most of the eastern United States is from the southeast, and then it kind of turns to the north as that cold front comes through, and then really you don't start seeing true return flow until right about here, which is Monday. So that gets you maybe 24 hours of return flow. So not necessarily super great for moisture return. So if that if that system weakens a little bit, it might be a little bit better for moisture return. But as it stands right now, just from one model, it doesn't look great for moisture, but we'll see. Now, in terms of surface-based CAPE, you'll see that we're not really seeing much CAPE until Tuesday, and you'll notice that here it's pretty low, and that sin is almost the same. The sin being the convective inhibition, the cap is quite a bit almost as strong as the Cape. So that's not great. That's not what you want. If you want storms, as you go, let me just not be biased towards northern Texas, which is what I see as the real risk area. But you can see it's pretty much the same across all of that 15%. So I'm not, to be honest with you, thoroughly impressed with that risk on Tuesday based on this model run. We'll see what happens. Maybe there's some elevated storms that will occur there. But overall, I think Wednesday appears to be the day. And you can see that here with the reduction in the convective inhibition, but the CAPE is still very low. So be a more than likely low CAPE high shear day. Not surprising for late February. So we'll see what happens there. And then just kind of as a way to finish this off, I wanted to kind of talk about the ensembles. And you can see here in the spaghetti plots, let me just move through this over here. You can see obviously pretty good agreement. These various ISO lines, this is 5520 height, 5.5 kilometer height, 5.7 and so forth. And you can see that as time goes on, the way that the ensemble predicts it, which is ensembles meaning multiple models looking at essentially the same time frame with slightly different initial conditions. You can see the variability in the prediction, and you can see that really as you start getting to Tuesday, there's some differences there in terms of timing. And that will really matter in terms of the kinematics and the timing of the trough coming through and associated lift, and that may have some implications on wind fields and orientation and things like that. So overall, I think that it seems that severe weather is indeed on tap for next week. The degree of that is somewhat unknown at this point. Seems like higher and severe weather will be possible given the very, very strong wind fields, but that may be limited, at least in a small degree, by the instability or lack thereof. So with that, I will end, and thanks for watching. Thanks.